and welcome to class. In this video we'll be studying about sine rule. Sine rule is one of the methods that can be used to calculate the value of the missing side of a triangle or even an included angle. So when you have a triangle with some given sides or angles, and then you are asked to calculate the other side or an angle, missing angle, you can use sine rule. Okay, so what I'm trying to say, look at, you have a triangle here labeled A, B, and a C. Alright, now the capital letters A, B, C, they stand for the angles. So for here you have angle A, here you have angle B, and here you have angle C. But for the sides, this is the convention for naming the sides. For the capital letter A, that is standing for the angle, the side facing that angle would have the small letter A. Then for angle B, the side facing angle B will have small letter B, while for angle C here, the side facing angle C will have small letter C. So in other words, we use capital letters to represent the angles, whereas we use their small letters to represent the side that is facing them. So in this case, we have side A, side B, and side C. Alright, so we have side A here, we have side B, and we have side C. Just like we have angle A here, angle B, and angle C. Alright, so you have to note this. Now, having said this, the sine rule states, this is the sine rule here, that A, that is the side A, over sine A is equal to B over sine B is equal to C over sine C. A over sine A is equal to B over sine B is equal to C over sine C. This what we have here is what we know as the sine rule. So we can use this to calculate the missing side or even a missing angle in a given triangle. However, there are some rules to consider. There are rules or conditions that must be met before we can apply sine rule to calculate a missing side of a triangle or a missing angle. There are certain conditions that have to be met, and I'm going to go ahead and list them. So the first condition is that first condition is a triangle. So where you can apply sine rule is in a triangle whereby all three angles are given. All three angles given, and one side. So all three angles are given and then one side. For example, what I mean by that is this: when you have a triangle like this, maybe you have angle here to be 30 degrees, here to be 100 degrees, and then you have here to be 50 degrees. So you have 30, 100, 50 degrees, and then you're having, so in this case you have three angles are given. Maybe you now have one side, maybe here it's given as 13 meters, and then you're asked to calculate the value of the other two sides. Maybe here it's called X and here it's called Y. You're asked to calculate their value. In this particular case, you can use the sine rule to evaluate the missing side. We are going to look at how that can be done, but just know that the first condition is that when we have three angles given and one side, that means that we can apply sine rule. The second condition is this, number 2 now. So when we have two sides given, so when the two sides of a triangle are given and an opposite angle of one of the given sides, let me try to write that, one of the given sides. All right, so I'll make a drawing to explain what I mean. One of the given sides. So this is the second condition. We can apply sine rule when we have two sides given and an opposite angle of one of the given side. What do I mean by that? Let's say we have a triangle here. We have this triangle, all right, and this triangle has two sides. Maybe here is 10 meters. Here is 14 meters, and then we're having an angle here. Maybe here is said to be 70 degrees. So in this case, we have two sides. We have two sides given, right? As you can see here, two sides are given, and this angle here, this angle 70 here, is opposite one of the sides. All right. So it could be, so it could have, in this case now we have 70 here facing 10 meters, or it could even be that we are having so the angle could also be written here. Maybe here is 60 degrees. In this case, we can also use sine rule. Why? Because we have two sides given, and one of the angles given is facing one of the sides, is opposite one of the sides. So either here or here, we can apply sine rule. But if we are given an angle here, this angle here, maybe here is said to be maybe 50 degrees. If there's an angle given here, we cannot apply sine rule in this case, because this angle here is facing no given side. This angle is facing this side, and this side is not given, is unknown. So we cannot use the sine rule for this particular case. But for when we have two sides given, or even three sides, and one of the angles given is opposite or facing one of the given sides, we can use sine rule. All right, so in this case, if here is 70 degrees, we can use sine rule. All right, now the other time we can use sine rule is condition 3, when we have two angles given. When two angles are given, and one opposite side of the given angles. So it's just like the opposite of what we have just looked at. Two angles and one opposite side of the angle. So of the angles, the given angles, when you have two angles given, that is what I mean by that. So you have a triangle like this. Maybe you have two angles. Here is 60, here is 50 degrees, right? So in this case, you have two angles that are given, and then if you should have a side that is opposite to either of these two angles, maybe you have a side here as 20 meters, then we can utilize sine rule. Or if you have the side here maybe 13 meters, we can also utilize the sine rule. But if we should have the side here maybe say 10 meters, we cannot use sine rule because we do not have any angle. Remember that in your sine rule, you always have a over sine a is equal to, so we always have the side and the angle, the side and the angle. All right, so these are the conditions that would warrant that we use sine rule. All right, so we have looked at the three conditions. The first one is when we have all three angles given and then one side. Then the second one is when we have two sides given and an opposite angle to one of the given sides. And the third condition is when we have two angles and one opposite side of the angle given. Now let's quickly go ahead and look at how then can we use the sine rule to solve problems. Now let's solve this example. Let's consider this triangle here. Consider this triangle such that here is 12 meters. Let's call here 30 degrees, and then here let's call it 45 degrees, and then let's call here Q. Now in this case we are asked to find Q. Find the value of Q. Find the value of Q. So they are looking for the missing side Q. You are looking for the side Q. How then do we find that? This is where we're going to use sine rule. Now remember that the sine rule is that the side over the angle is equal to the other side over the angle given, and like that. So if you want to use sine rule here, what we're going to write is that Q over, okay, that's a bit big, Q over sine Q. Remember that our sine Q now, but if here is small letter Q, that means that this place here is the capital letter Q. Alright, so Q over sine Q, and Q there is 30, is equal to, now this side we have full information given, so that will give us 12 over sine 45. Alright, so Q over sine 30 is equal to 12 over sine 45. Now remember that in our sine rule we have three items given: A over sine A is equal to B over sine B is equal to C over sine C, but whenever you're solving you just need two, and in that two that you need, one of them must have complete information. Alright, so in this particular example we are trying to solve, you see that this particular one here has complete information, while here one is missing, just the Q. So whenever you are using sine rule, there must be one of the given parameters that has all needed variables given. So going further in this case, what we can do is to cross multiply. So cross multiplying, we have Q sine 45 is equal to 12 sine 30, right? So we have Q sine 45 is equal to 12 sine 30. We're looking for Q, so dividing both sides by sine 45, what we have is that Q is equal to 12 sine 30 over sine 45 degrees. Alright, 12 sine 30 over sine 45 degrees. So when you punch this in calculator, 12 sine 30 divided by sine 45, you have a Q to be equal to approximately 8.5 meters. Our Q becomes 8.5 meters in this case. Alright, so let's look at another example. Let's say that we have this triangle. We have this triangle. Okay, let me put it. We have this triangle. We have this triangle labeled A, B, and C. Labeled A, B, and C, such that here is 55 degrees and here is 75 degrees, and then we have here to be 50 degrees. Now we are asked to find, let's evaluate A. So we should find A. Okay, and of course here is giving us 13 meters. So we're looking for A in this case. How are we going to solve this? This happens to be a clear case, so we can use the sine rule because we have three angles given and one side. So we have complete information. So this side is complete, the angle is complete. So we can use that as our benchmark to find this here for this side is not given, but the angle is given, so we can utilize sine rule. So in this case, we want to set our sine rule. It means that a over sine a. Remember, you are always using two parameters. A over sine a is equal to c, that's the side c, over sine c. Now, why wouldn't you use b? You are not going to use b because even though the angle b is given, but the side for it is given. I remember, and just like I said, for your sine rule, one of them must have a complete information, and in this case, the c and the sine c are given. So you will always make sure that one of them has complete information. If you use b, your side for b is not given. So going ahead to put in the values, constructing the values, a is not given, so a over sine a is sine 75, because a is 75 degrees. So a over sine 75 is equal to c is the side facing us here, so that's 13. Remember that the small letter stands for the side, over sine c. In this case, the sine c, as c is 55 degrees, so that will give us sine 55 degrees. So going ahead, we'll cross multiply. When we cross multiply, this will give us that a sine 55 is equal to 13 sine 75. Now note that a sine 55 means a times sine 55, while 13 sine 75 means 13 times 75. Alright, now to get our a, we'll have to divide both sides by sine 55. So that would mean 13 sine 75 over sine 55. Now going ahead to punch the values in your calculator, you are going to get approximately a is equal to 15.3 meters. A is equal to 15.3 meters. All right, so that's as a case of how we can use the sine rule to find the missing sides. All right, now we don't only evaluate or try to get the missing side using a sine rule. We can also try to use sine rule to solve for a missing angle. Let's look at that case where we can be asked to evaluate a missing angle. Consider this triangle. Let me bring it down. Consider this triangle. We are labeled P, Q, and R. P, Q, and R. Alright, such that R is equal to 40 degrees. R is 40 degrees, and you have side R to be 10 meters, and you have here, and then you have here to be 15 meters. So we have to find the value of P, Q, R, angle PQR. Remember that the angle is always at the middle letter. In other words, we're looking for the value of Q, that is here. That's what we're looking for. Find PQR. So how do we solve this? The same thing. Now looking at you, first of all, identify which side is complete, which side has complete information. You see that your R side R is given, angle R is given, so the R has a complete information, whereas you are looking for Q. The Q has a side, but the angle is missing. So if you want to state your sine rule for this particular case, it's going to be that Q over sine Q is equal to R, because we're using R as our bench now, because R has complete side. To have R over sine R. Going ahead to put in the value, so Q is 15, so that's 15 over sine Q. Sine Q, we don't know what Q is, so we're going to still maintain the letter Q there. So sine Q is equal to R now is 10 over sine R. Sine R is sine 40 degrees, because our R has the value of 40 degrees. Alright, so going ahead, we'll cross multiply. So cross multiplying now, we have 15. So it means that 10, that will mean that 10 sine q, 10 sine q is equal to 15 sine 40. 10 sine q is equal to 15 sine 40. Therefore, for us to get our sine q, dividing both sides by 10, it now means that sine q, because we're looking for q, sine q is equal to 15 sine 15 sine 40 over 10. Now when you punch this in calculator, 15 sine 40, that's 15 times sine 40 divided by 10, it means that sine q is equal to 0.9642. 0.9642. How do you get your q? Remember, in this case, when you're looking for your q, what's the next thing that you do? Your q, therefore, is equal to the sine inverse. That's your arc sine. In your calculator, you're going to press shift sine, so you get this figure, which is the inverse of the sine. So the sine inverse or the arc sine, this value 0.9642, and when you press that calculator, this arc inverse of 0.9642, it gives you that your value of q is equal to approximately 75 degrees. All right, so 75 degrees IQ. And if maybe in case maybe had it been that day, we also expected to find P, angle P. Now if you have to find angle P, what are you going to do in this case? Having gotten your Q to be 75 degrees, how then do you evaluate P? This is, you're looking for this P. Sum of angles in a triangle must always equal to 180. So sometimes you could see they will ask you find two angles. So once you get one of the angles, once you have two angles in a triangle, you can always evaluate the third angle by just summing everything up to 180 and then solve for the missing side. So in this case, if you want to find P, what that would mean is that P plus Q plus R is equal to 180 degrees, right? And our P, we don't know what it is. Our Q, we know it to be 75, plus our R, which is 40 degrees. That all together must give us 180. So it means that P plus 75 plus 140 plus 40, that will give us 115 is equal to 180 degrees. Now subtracting 115 from both sides, what we have is that P is equal to 180 minus 115, and that means that P is equal to 180 minus 115. That gives us 65 degrees. All right, so that gives us 65 degrees. So we have been able to see that here also will now become 65 degrees. So this is just to show that we can use sine rule to evaluate both the missing side and missing angles once the three conditions are met, where you have all three sides given and one included angle, you can utilize sine rule. Or when you have all three angles given and one side, you can use sine rule. Or when you have two angles given and one side opposite to the given angle, you can use sine rule. Or where you have two sides given and one angle opposite to the given sides, you can also use sine rule. All right, so take your time and go over the video. Don't forget that this here is the formula, and sometimes in some textbooks you see it being written in this manner. Sometimes you see it being written in this manner, upside down. Sine A over A is equal to sine B over B is equal to sine C over C. It does whether like this or this one here, it is still the same thing, whichever way you use it. But the thing is that you must be consistent. You cannot say sine A over A is equal, you now go and turn it and say B over sine B. No, if you are taking the angles up, then all the angles should be up. If you are bringing the angles down, they should be down. So you don't mix them up. Alright, so whether like this or like this, you are still correct. So that's about the sine rule. So go over the video and try to see how that works. So I'm going to give you some practice questions. So try to find the missing sides in the given diagrams. Alright, so in this particular diagram, if here is given as 60 degrees, here is given as 40 meters, and here is given as 35 meters. 35 meters. Find so find the angle here. Let me call it X degrees. So find the missing angle. In this case, number 2, look at this triangle here, labeled A, B, C. So if we have B to be 50 degrees and A to be 90 degrees, such that we have here to be 17 meters, find B. So find the lettered angle. So in this case you are looking for B, find B. Then let's look at this one as well, number 3 now. So if we have a case of in case of 50, 70 and 60 degrees, and then we have one side given, let's say here 50 meters. Find lettered angles A, and let me call this X, and also find Y. So in this last example, number 3, you might have to reason it out properly. So that means you take it one after the other. You solve for X. When you're done solving for X, you solve for Y. Alright, so solve that and get across the answers. Get the answers across to me. We will continue in the next video. For now, bye.